Honors Geometry, section 12.3 notes. We got review some of the terms we had in the last section, and then we're going to add some more terms to this, throw in a theorem, maybe a postulate. I mean, the possibilities are endless. Arc, an unbroken part of the circle. So minor arc. So for example, arc high is a minor arc. I'm not going to name them all. MG, arc MG is a minor arc. MH, arc is a minor arc. Major arc, an arc that measures more than 180. So we can see that segment GH is a diameter. So any arc that crosses through that and goes past it would be a major arc. Major arcs stand by 3 letters, minor arcs with 2. We could call this arc G high. Semicircle measures exactly 180 degrees, half the circle. These should be degrees here. So a major or a semicircle would be arc HIG, high G. There you go. Good enough. Name each of the following from the picture. Let's name all the minor arcs, and my picture is lacking a bit. Let me add this to the picture, and we'll call this point of intersection G. Minor arc, arc DG, arc GE is a minor arc, arc FE is a minor arc, so I just named this one, and this one, and this one as minor arcs. Major arcs, major arc. We got arc DEF, will be this fella right here. Let's see, we could go this route, FDE. There's a couple majors. Semicircle, we could go this route, or we could go this route. It will be semicircle GDF or semicircle GEF. Arc length and arc angle are different. Arc measure is referring to an angle. Arc length is referring to a distance. So let me try to illustrate the difference between these two. Let's say that we have the center here. Let's say this is 90 degrees. And let's say the radius is 10. And we wanted to know the arc length. To find the arc length, and when I say arc length, let's say the arc length of AB. Arc length is part of the circumference. Circumference is the length all the way around. So if we wanted to find the entire circumference, it's 2 times pi times r, and we're saying the radius is 10. That would make this 20 pi. The length all the way around the circle, from here to here, and then here to here, and then here to here, and here to here is 20. Well, if we have a 90-degree angle there, that 90 degrees represents 1/4 of the circle. It's 1/4 of the way around, because 90 and 90 and 90, 90 is 360. So that means the arc length we're looking for is 1/4 of the total circumference. A fourth of 20 pi would be 5 pi. Let me illustrate that with a formula. The length of arc AB would be the degree measure of the central angle, 90, over the entire circle, 360, times the circumference. So that's 1/4 of 20 pi, which is 5 pi. The length of arc AB is 5 pi. As opposed to arc measure, the measure of arc AB, which we call measure of arc AB, that's different than the length. Contrast that. That is the angle measure. And we're going to learn this here shortly, but the angle measure of an arc is the same as its central angle. So the measure of arc AB is 90 degrees. Arc length, linear measurement. Arc measure is in degrees. Pardon me. Adjacent arcs. Arcs of a circle that have exactly 1 point in common. So, for example, arc high and arc IG are adjacent arcs. Next we have arc measure. The measure of an arc is the measure of its central angle. The measure of a semicircle is 180 degrees. So for example, if the central angle is 40, then the measure of this arc is also 40. The measure of angle B is 40 degrees, and so is the measure of arc AC. Arc addition postulate is exactly what it sounds like. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So for example, let's say that we are going to add the measures of these two arcs. The measure of arc HI plus the measure of arc IG is going to equal the measure of arc HIG. Same concept as the segment addition postulate and the angle addition postulate. So far, the only thing that might be kind of earth-shattering is this right here. An arc measure is the same as its central angle, and that's pretty simple. Theorem 12.1. In the same circle, or in congruent circles, two arcs are congruent if and only if their corresponding angles are congruent. Two arcs are congruent only if their corresponding central angles are congruent. So let's draw, so we have a central angle. Let's call this circle C. Let's call this diameter JK. So if these central angles are the same, then that must mean that this arc and this arc are the same. So angle JCH is congruent to angle GCK if and only if arc GH is congruent to arc GK. Remember, if and only if means you can say this forwards or backwards. The measure of a central angle of a regular polygon, measure of angle C, that's the measure of the central angle, is 360 degrees divided by the number of sides. So for example, in this picture, this is a regular triangle. The measure of a central angle is 360 divided by 3, which is 120 degrees. So this is 120, and this is 120, and this is 120. That should make sense because 120 and 120 and 120 is 360. Moving on to some examples. Concepts are pretty easy, but the problems can get complicated. What's the measure of arc CE. The measure of the arc is referring to degrees, not an actual length. CE consists of the measure of arc CD plus the measure of arc DE. CE is 53 degrees, DE is 34 degrees. If you add those together, I believe you're going to get 87 degrees. So from here to here is 87 degrees. Measure of arc EF. Well, let's check this out. I think you would agree that this is a semicircle from here to here. This makes that 180, which means this must be 93, because 93 plus 87 is 180. If you want work for that, we got the measure of arc CE plus the measure of arc EF equal 180. It's 87 degrees plus the measure of arc EF is 180. Make sure your arcs look like arcs. I'm not doing a good job. So the measure of arc EF would be 93. Once you find this information, put it into the picture. What's the measure of arc ECK? Let me highlight that. ECK. I don't know at this point. What's the measure of arc DFC? Also don't know at this point. Actually, no, I do know that one at this point. DFC, that's everything around the circle but the 53. So that's 360 degrees. We're not using the 53. That means we're left with 307. So let's go back to this last question that I skipped, ECK, which is this right here. If you notice, this is a semicircle, this blue part, which is 180 degrees, and it's broken into 3 equal parts because there's 2 dashes on each of these. 180 divided by 3 is 60. So that makes this 60 degrees, and this 60 degrees, and this 60 degrees. So this purple arc that we're trying to find is going to be 87 plus 60 plus 60. That's 87 plus 120. I believe that's 207 degrees. So a lot of calculations need done for that, and it's easy to make mistakes on calculations. This one, all right, let's work through this before we answer the questions. This arc is 2 dashes, and so does this one, which means the central angles have to be the same. That was the theorem we had on the previous side. Central angle is the same as the intercepted arc, so these are each 39. This is a diameter, which makes this a semicircle. So that makes this right here the measure of angle, measure of arc KE. It's going to be 180 minus 39 minus 70, which I believe is 71. Let's see, 71 and 39 will be 110 plus 70 is 180, so that works. Let's see if we can answer the questions. Measure of arc AC, easy, same as the central angle, 39 degrees. Measure of arc AE, So that's one that we don't have answered. So from here to here, semicircle is 180. So the measure of arc AE is going to be 180 minus the 39 that you see there. It's going to be 141. Measure of arc EK, we have that marked to 71. We already did the work up here. Measure of angle KBD. Well, that's 39 because we use the theorem that says if two arcs in the same circle are congruent, then their central angles have to be the same. Given a regular polygon, complete each equation. Regular polygon means that each side of the polygon is the same length. So before we start answering these questions, let's see if we can figure out some things that we know. The measure of a central angle, so like angle DTC, it's going to be 360 divided by the number of sides. There are 6 sides because it's a hexagon. And that's going to make each of these angles 60 degrees. So this is 60, and 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 this is 60. They're all 60. Which makes the measure of each of these arcs 60 as well. Now let's see if we can answer some of these questions. What's the measure of angle ATB? ATB. Well, that's 60. We just figured that out. What's the measure of angle DTB? That's this angle here, which is 60 and 60, which is 120. Measure of arc AC. That's a 60 and a 60, which is 120. Measure of arc ECA. ECA. That's 1, 2, 3, 4 60s. 4 times 60 is 240. Measure of angle AEB. AEB. Measure of angle AEB. So let's focus on that triangle. See if we can figure this out. Now I know a way to do this, but you don't know how to do it yet. Oh, I see. Oh, okay, here's how we can get this figured out. So let's focus on this triangle right here. This triangle has to be isosceles because those two things I just marked are the radius. Radius are always the same length. That makes the base angles of this triangle have to be the same. So if this angle here is 120, 60 and 60, there are 60 degrees left for these other two angles that have to be the same, which makes each of these 30. The question asked the measure of angle AEB. That is then 30 degrees. If the length of AB is 5, what does TB equal? Let's focus on this triangle, this big blue one. Do you see what kind of triangle we have here? I'm just going to rewrite it, this triangle. we have a 90 and a 30. That must mean this is 60. And a 30, 60, 90, whatever's opposite 30, opposite 90 is twice that. That makes that 10. So this diameter here is 10, which makes the radius half of that, which is 5. Another way to look at this, if that's just too much for you, focus on this triangle. This triangle has to be isosceles, because those two sides are the same length, which means the base angles are the same. We've used 60 degrees, there's 120 left. You divide that by 2, that means each of these have to be 60. It's equilateral, which makes all the sides 5. Last one. If AB is 5, what is EA? This is the same picture, but I just drew it again, apparently. AB is 5. What is EA? This goes back to this, what we said earlier. This is a 30, 60, 90. This meaning this fella right here. Short leg is 5. This is the short leg times the square root of 3. That makes EA 5 square roots of 3. You've got to know your special right triangles. That concludes the notes. That concludes the chapter. Do the homework for 12.3. Thank you very much.